Welcome back. This video is lesson 1.6. We're going to be talking all about equivalent ratios today. Please fill out your table of contents. We're going to be on page 29 and 30. That will be equivalent ratios as the title. So go ahead and fill that out and then get the 2 green papers that I gave you in class ready to take notes. Today we are talking about equivalent ratios. And since a ratio can be expressed as a fraction, we're going to be showing those rates as fractions for the most part today, because it's easy for us to tell whether fractions are equivalent. So equivalent fractions and equivalent ratios kind of go hand in hand. So here is your green note sheet. We're just going to have to trim the right-hand side for it to fit in your notebook. We're going to start off by talking about 3 different ways you can tell if ratios are equivalent. So the first way you can tell is to try to find unit rates. We're going to see an example of that. The second thing you could do is actually compare the fractions and see if the fractions are equivalent. And the third thing we're going to get a little taste of today is this thing called cross products. So we can check if rates are equivalent by doing cross products. So underneath this, there's numbered 1, 2, and 3, and we're going to go through each one. There's not a lot to write in, but I do want you to follow along as I talk about how to find unit rates. And I'm going to circle some things, and when I'm circling them on my note sheet, make sure you are as well. So when you're using unit rates to find if ratios are equivalent, you're going to basically find the unit rates of both, and if the unit rate is the same, that means the original rate is also the same. So if the unit rates are the same, then the original ratio or rates are the same. That's literally what we can write when we're asked to explain our reasoning. Since I found the unit rate, and those are the same, therefore the original rates are the same. It's going to be kind of a cookie cutter way of explaining ourselves in this lesson. So Felisa read the first 60 pages of a book in 3 days. So 60 pages in 3 days. She then read 90 pages in 6 days. So that's the second rate. That's the second rate or ratio that we're given. Are these reading rates equivalent? So notice these words are actually within the fraction. That's okay too. I pull them out and start with the words first. But we have 60 pages in 3 days. When you divide by 3, that equals 20 over 1. You do the same for the other rate. It's 90 over 6 goes down to 15 over 1. We found the unit rates, but unlike this, they're not the same. So when they're not the same, literally you say, since the rates do not have the same unit rate, they are not equivalent. So it's the opposite when they don't equal. So Felisa's reading rates are not equivalent. So it's very straightforward. If you're finding unit rates and they're the same, then the original rates are the same. If you find the unit rate and they're not the same, then the original rate is not the same. Number 2, if you can't get a unit rate easily, if the numbers aren't really working for that way, you can find equivalent fractions to see if they're the same. So basically what you're doing is you're comparing fractions to see, and if the fractions are equivalent, similar to the other explanation, then the ratios are equivalent. So you're using equivalent fractions to prove that the equivalent rates are the same as well. So let's look at this example. 3 free throws made out of 7 attempts. That's the first ratio. Then we have 9 free throws made out of 14 attempts. So we're doing throws and attempts. We have 3 and 7 for the first, and we have 9 and 14 for the second. What we've done here is, how do you get from a 7 to a 14? Well, you can times 2. How do you get from a 3 to a 9? Oh, you can times 3. But since these numbers, 3 and 2, are not the same, you know that these fractions are not equivalent. So the numerator and denominator are not multiplied by the same number, so the fractions are not equivalent. And the explanation for when it doesn't work out, since the fractions are not equivalent, the ratios are not equivalent. So I want you to circle our explanation sentences. So we can do this one if it does work out, or we can do this one if it doesn't work out. So these sentences you can literally use when you're asked to explain your reasoning. Now we can check, our third way to find equivalent ratios is we can check that two ratios are equivalent by using cross products. So cross products, it actually makes an X like a multiplication sign. You can see my two pictures here. I know your version is black and white, so I want you to grab some sort of color, either crayon, color pencil, marker, does not matter. But I want you to shade the actual box 6 and 16. And I'm just going to shade over here so that this diagonal pairing of the 6 and the 16 gets multiplied. So it's over here, 6 times 16. And then grab a different color and actually shade the 4 and the 24, because those will get paired up and multiplied together on the other side. So you have two multiplication problems, and we want to see if they are equal. 4 times 24 and 6 times 16. Since our cross products, get the pattern here, since the cross products are equivalent, then the rates are equivalent. So over here, it's just letters instead of numbers, but the A and the D, the diagonal numbers get multiplied, and then the diagonal numbers going in the opposite direction get multiplied together. That's a little taste of cross products. Here's an example. Jim ran 3 miles in 33 minutes. This is the first rate that we're giving Jim. So 3 miles in 33 minutes. Alice ran 2 miles in 22 minutes. Are these rates equivalent? Explain your reasoning. So I'm going to start with words first. Does not matter whether you do miles over minutes or minutes over miles. I'm going to do a unit rate. So I'm going to put the bigger number, my minutes, over miles. But in my notebook, I actually did it the opposite way, and it still works out fine. So now we're going to talk about Jim. So Jim's rate is 33 over 3. I want to get this to a unit rate. How do I do that? By making my denominator a 1. So 3 divided by 3 is 1. What I do to the bottom, I have to do to the top. So I have the unit rate of 11 over 1. Now I have to do the same thing for Alice. So Alice, same minutes over miles. I want everything to be the same so I can compare. So she has 22 minutes and she's running for 2 miles. So again, I want a unit rate. So my denominator is 1. I'm going to divide by 2 over 2 this time. And lo and behold, yay, how cool is that? We have 11 over 1 as well. So now we're going to explain our reasoning. So since the unit rates are equivalent, the original, what we started with, rates are equivalent. And all I'm going to do is I'm going to add a yes to the beginning of this, because are these rates equivalent? Yes, they are. We have to answer that question as well as explain. So yes, the answer is they are equivalent, and here's our explanation. Since the unit rates are equivalent, the original rates are equivalent. If they did not match, we would simply put a negative in front of that. Since the unit rates are not equivalent, the original rates are not equivalent. So that's the cookie cutter explanation sentence that you can borrow and use. Now I'd like you to try this one on your own and pause the video and push play when you're ready to check your answer with my explanation. Determine if the rates 5 laps swam in 8 minutes and 11 laps swam in 16 minutes are equivalent. Explain your reasoning. Okay, so this one, we're going to be comparing laps and minutes. So I'm going to start with those words. And we have 2 different ratios. We have 5 laps to 8 minutes. And we want to see, is it the same as 11 over 16? So my fractions are a little bit more difficult to try to put into unit rates. We could, but I'm going to go the equivalent fractions way of showing this, and then I'm also going to do the cross product ways of showing this, just to give you the variety. So equivalent fractions, I want to see what times 8 will give me 16. See if that's an equivalent fraction. So I can multiply this by 2. But if I do the same thing, this is the problem. It should be a 10 if they're equivalent, and it's not. So here will be my written explanation to the answer. So here's my explain my reasoning sentence. So, since the fractions are not equivalent, the original rates are not equivalent. So instead of using unit rates, I'm using equivalent fractions. Since the fractions are not equivalent, the original rates are not equivalent. Now I'm going to just slide over here and show you how we could prove that with cross products as well. And I'm just going to continue the problem over here. When I am so here I have the same fractions. Instead of finding equivalent fractions, I could circle the 5 and the 16. So I do want you, when you're trying cross products, you have to circle what numbers you're multiplying together. So 5 times 16, I want to see, is that equal to the opposite? And notice it forms that X. So do that, okay, when you're doing cross products. So now on the other side, I want to multiply 8 and 11. Now, just so you know, that dot that I'm doing, that also means multiply, okay? So 15 times 16, that is 80. And now we have 88 on the other side. They are not the same. And so my explanation is, since the cross products are not equivalent, so instead of writing fractions, I would just replace that with the word cross products. Since the cross products are not equivalent, the original rates are not equivalent. So we're going to practice this more in class tomorrow. I hope you have a wonderful evening. I'll see you then.